In this video, we'll practice an application of indefinite integrals. Here's our example. During launch, a rocket's acceleration is 8.1 t squared meters per second squared upwards. Find the height s of the top of the rocket after 3.6 seconds if s equals 13 meters initially and the rocket's velocity after 2.0 seconds is 19 meters per second. We'll start with the acceleration, a, then we'll integrate with respect to time to get our velocity v, and then we'll integrate with respect to time once more to get our displacement s. We'll be starting with the fact that the acceleration a is 8.1 t squared. We're trying to find the height s after 3.6 seconds, so I'll put a question mark there so we know that's what we're trying to find. We know that s initially is equal to 13 meters, so s of 0 is equal to 13. We also know that the velocity after 2.0 seconds is equal to 19 meters per second, so v of 2.0 is equal to 19. And that way we've pulled all the information out of the question. So beginning with a equals 8.1 t squared, we can say that velocity is the integral of acceleration with respect to time. So that makes v equal to the integral of 8.1 t squared with respect to time. That makes v equal to 8.1 t cubed over 3 plus some constant. Now I'm going to call our constant C1 because there may well be several constants that come up in this calculation. Let's simplify v and call it 2.7 t cubed plus C1. And now what we can do is use this fact that v of 2.0 is equal to 19. So let's sub in v is equal to 19, t is equal to 2.0, and that should give us enough information to find the value of that constant C1. Subbing in, we've got 19 is equal to 2.7 times 2.0 cubed plus C1, and then doing a little bit of algebra here, C1 works out to negative 2.6. So let's take the value of this constant, we'll plug it back into our expression for v, and we now know that v is equal to 2.7 t cubed minus 2.6. So I'm going to put a box around that, and we've now got an expression for v. Now we can use the fact that displacement s is the integral of velocity with respect to time. So s is equal to the integral of 2.7 t cubed minus 2.6, and that's all being integrated with respect to t. Doing our integration, s is equal to 2.7 t to the fourth over 4 minus 2.6 t plus some constant. So I'm going to call this constant here C2. It's important to give it a different name than the constant C1 that we used earlier, because this new constant C2 may well have a different value. In fact, most likely will have a different value than the constant that we used earlier. Now let's use the fact that s of 0 is equal to 13. So we will sub in s equal 13, time equals 0, and that's going to help us find C2. Plugging in here, we'd have 13 is equal to, well, first term is 0, second term is 0, and we've just got C2. So that tells us that C2 is equal to 13. We'll take that value, plug it in back up here, and that will give us a formula for s. So s is equal to 2.7 t to the fourth over 4 minus 2.6 t plus 13. Alternatively, we could have actually simplified that decimal, so if you want you could write s equal 0.675 t to the fourth minus 2.6t plus 13. Either way is fine here, since both expressions are exact. Finally, to get our answer, we'd like to figure out the height or the displacement after 3.6 seconds. So plugging in here, we get about 117. So that's 117 meters. Or alternatively, we could write our answer to 2 sig figs, so you could say 120 meters. So we found the height S, which you could think of as the displacement of the top of the rocket after 3.6 seconds, 120 meters.